Welcome to this talk titled Build a Command Line App with Go. My name is Josh Duffney. I'm a senior content developer at Microsoft, Pluralsight author, and former Microsoft MVP. You might be asking yourself, why is there a Go talk at the PowerShell and DevOps Summit? And that's a fair question. I, myself, was rather surprised when I got an email that the talk had been accepted. But I have a few ideas as to why Go is an important next step for those who know and love PowerShell. When I left college, the last thing I wanted or expected to be doing was writing code all day. Typing what seemed to be a foreign language into a terminal for hours and hours seemed like a special version of hell that I wanted no part of. But fast forward 12 years, and that's exactly what I love doing most about my current role. Over the last decade or so, I've been walking the stack, so to speak. I started on the help desk, moved up to system administrator, then moved to systems engineer, and before my current role, I was an SRE. And at the present moment, I'm making that final step into learning to write software, the software that I've always been supporting and administering and engineering my entire career. For me, and probably for you, automation was what changed my mind about coding. As wonderful and powerful as PowerShell is, there is always room on your tool belt for another tool. And what I want to convince you of is that Go is a great addition to your skill set. But from a career perspective, is it better to specialize or generalize? In his book, Range, Why Generalists Triumph in a Specialized World, David Epstein lays out a compelling argument for embracing generalization, at least to a degree. In his book, Epstein tells a story of Andy Kortekirk, a widely recognized senior scientist at 3M, a multinational conglomerate. Andy wanted to know what types of scientists are more productive, so he began his own internal research at 3M in search of an answer, and his findings surprised him. He discovered three types of scientists: generalists, specialists, and polymaths. Generalists and specialists both made adequate contributions, but the most successful innovators were polymaths by far. People with deep expertise in one or more areas and even more breadth than a generalist. You can see this pattern repeated everywhere in the tech industry and probably even within your own organization. In a complex environment, it's those who have the most range that thrive. My reason for bringing this up is to avoid overinvesting in specialization in hopes that it will provide a promising future, and that it might be time to broaden the T part of your T-shaped knowledge before it becomes too deep in one particular area. So let's assume that I've convinced you to pick up a new language and that picking up a new language is a good idea. But why Go? Well, Go is one of the few languages that you can learn inside the same context as your current role. On the right-hand side, you can see how Go is connected to many of the tools in the DevOps space. Go is connected to, most notably, to Kubernetes, Terraform, and even GitHub's CLI tool are all written in Go. That means that by learning Go, you can deepen your understanding of a particular tool while at the same time expanding your range. In short, it's a twofer. If you go on YouTube and you watch any Learn to Code video, everyone tells you that you need to practice, to get your hands dirty, to build projects. But when you're approaching an entirely new language, it's easier said than done. When I first picked up Go, less than 6 months ago I might add, I had no idea where to start, and that's the problem I want to solve for you in this talk. You know PowerShell, which means that you could appreciate a great command line experience. So why not try to build your own? And that's what we'll do in this upcoming demo. We will take a look at how we can build our own command line tool in Go that uses Azure Blob Storage. So here we are in every PowerSheller's favorite IDE, VS Code. And the first thing that we're going to do is open up a prompt. So Go has a number of environment variables that you can see if you do go env after Go is installed. But if we look at this, there's a lot of environment variables here, and all this configures Go in a different way. The one that I want you to focus on for now is the path. So if we do go env, well, that's weird. Go env grep path, and it's capital, and I'm on a Mac, so that matters. And then if we look at this, there's only one directory listing in here. So the Go path variable lists all the workspaces, the Go workspaces that you will be running your Go code from. Now, I only have one in here, and that is a Go folder underneath my user's home directory. So if I change into Go, now I'm in my workspace. So a workspace is just a place where you're going to be running and developing your Go code from, and it just gives Go awareness of where that code is so that it can execute it. Now, if you look at the directory listings here, bin and package are directories that come installed when you install Go. They're created for you automatically. Bin is where all the binaries go, and PKG is where all the packages go, where all the dependency packages and so forth will go. I created the source directory. This is for creating a Go workspace. If you use Go modules, you can kind of put it wherever. You just have to make sure that you update your Go path variable, and then you can develop from wherever you want on your file system. So I'm just going to go into my source directory here and we'll take a look. So if we ls in here, I have a couple directories. I have GitHub and then I have Hello Gopher. Hello Gopher was just some code left over for a workshop I was walking through. And so if we look at GitHub though, you'll see that there's kind of this like repository, organization, and then repo structure. So if you're familiar with Git and GitHub, there's github.com. And then if I were to browse the URL into an organization like my username, so if we just ls on GitHub, you'll see that. And if we expand on Duffney, we'll see the repositories of my user that I have pulled down and that I'm developing on. But for the sake of this, I'm not going to attach it to a repository. We're just going to create a new directory and work out of there. So I'm going to do mkdir and create azblob CLI, because what we'll be building in this particular demo is a command line app in Go that allows you to manipulate Azure Blob Storage. So that's the kind of the name of the package here. So now that I have that, I'm going to change into the azblob CLI. And I'm going to create, I'm going to initialize a module. So a Go module is a way that it manages the packages. And if you're going to write a new module, something that executes, you need to do go mod init. So go mod init, and then I'm going to give it the name. You don't have to give it a name. I am, because I'm going to give it the package name of azblob CLI. So azblob CLI. And now I have this new go mod file. So the go mod file, if we cat that, you can see that it has kind of version lock for the version of Go that I have installed when this module is created. So it version locked me to that. It will also, as we continue to develop on and I add in other packages like azblob that will allow me to use the Azure SDK for Go to manipulate blob storage, that'll become a dependency and pulled into this Go mod file. So now we've kind of set up our workspace, we're ready to develop, and now we can create our first Go file that we can actually write Go code in and start to develop our application. So I'm going to do code insiders, because I'm using code insiders. If you're just using VS Code, it would just be code. And then I'm going to do main.go. And then in a minute, I will have my main.go open. My file, I'm going to save it just to make sure that it goes on disk, which is fine. And so now I have to write my code. Now, at this point, this is kind of the scary part, right? Like, how do we do this particular thing? Our aim in this demo is to write a command line app that is able to upload, download, list, and delete blobs from Azure storage. And so for that, if we're going to build a command line app, it might be good to have some kind of a design pattern to maybe look at. And for that, I would recommend a website called Go by Example. It's a really great resource, and we'll use that to kind of model our stub function, and we can kind of pseudocode our way through what we would do. So I'm going to minimize this and snap it to the right of my screen, and then I will use Go Example on the other side. So here we have Go by Example. It's gobyexample.com. And if we look through here, towards the end, there is an example of creating a subcommand. So that's what we want to do. We want to create a command that's azblob CLI that then has a subcommand of the function that we want to do, which would be upload, download, list, delete. Those are kind of the functions, the subcommands that we want to build into here. And so instead of trying to figure it out on our own, we might as well look at an example and see how, one design pattern of how we implement it. So if we look at this, the Go by Example uses, I believe, all of the just standard library. So there are other packages out there like Cobra and frameworks that you can get really in depth and Go. And then that will make it a lot easier to write these particular command line apps. But when you're learning, it's best to go back to the basics and learn how to leverage the standard library to do this. And by standard library, I mean, it's a set of packages that comes with Go. And it's very much like if you were to just get PowerShell installed on a system, it would be what you have for free. It would be where you don't need to go use install module and pull down a bunch of different external module dependencies. It kind of just comes with the system when you install it. So if we look at this particular example shows you how to do a command line app with subcommands using the flags package, the fump package, and the OS package. And so those are all standard library packages that we'll take a little bit more of a look at in depth. But if we look at this, we can see that we have our main function. So this is how we would write our main function. And so we can kind of copy that over here, package main, and we want to import, and we're going to import these three particular packages, flag, fumped, and OS. So now we have our packages, and we want to declare a main function because that's how everything is executed. It's like the program.cs, if you're familiar with C# and .NET stuff. Now what we want to do is kind of look at and just get an idea of what this is doing. So if we look at the flags package here, we can start to get an idea of what's going on and how it's building commands. So you can see at the top here, we have this foo command, and then we have this bar command. So it's using that as a way to show this is how you create your new subcommands. So each of these is basically creating a subcommand, one for foo and one for bar. And if we look down at running the example, you can see how that kind of translates to execution. So you're very familiar with using command line. Now we're trying to switch gears into like, how would we actually develop these particular commands and to build these subcommands? So we can see that foo here is a subcommand, and it takes these different arguments of enable and name. And if we look back up here at foo enable, it's building off a Boolean that is enable. By default, it's false. And then its description is just enable. And if we wanted to kind of figure out like how would we build these and we want to get more in-depth understanding of this, we would go to package.dev and look at the flags package. So here we are on package.go.dev. And this is the flags package documentation. So this, you can think of this as the get help for Go. This is where you're going to go for all of your documentation needs on standard libraries and even third-party libraries. This website has it all. And you can see down here that there's a kind of a table of contents of sorts. So you go to documentation, you can look at the functions and types. The best way that I find is I typically find an example of whatever it is I want to learn, and then I just search the documentation set for that. So new flag set is a function underneath the type of flag set. So if we click that, we'll be able to see how they were using it in that example. So you can see here that the function flag set takes a name that is a string. So it gives you, it's the arguments that you need to pass in and then the types that are there. So name is a string, and then it also needs to find out this error handling. And error handling it's another type that has several constants that it accepts. So you can continue on error, exit on error, or panic. So those are your options for that particular argument here. And if we go back to the example, we can see that that's what they were doing is they chose to exit on error for both of their subcommands, foo and bar. So now using this, we'll kind of transfer this over and we'll write out a stub function for our AZ blob storage. And what we'll do is we'll mimic this down here so we can just see what it would look like to execute without any functionality behind it. We want to just get through the reps to make sure that our commands are lined up, our ducks are in a row as far as when we would run and execute this command, and then we could print out the different levels of that subcommand and the arguments that are being passed in. So then we can kind of build our functions around that. So using this example as a design pattern for our command line app, we'll start to just build out our subcommands, and then we'll worry about their flags after the fact, or their options that we would be passing into the functions. So to start, let's create our upload. Remember, I wanted to kind of do 4 different things. I want to upload, download, list, and delete. So let's start with the upload command. So we'll just name this variable upload CMD, and we're going to make a new flag with it, new flag set. And this is going to be the name of this. Remember, the first part was the name string. So this is going to be upload. And we want it to exit on error. So that's the first subcommand. We'll leave a little space for the options later. The next one was download. All right, there's that one. We wanted list. Also exit on error. And then we want to delete. Okay, so now we have our 4 subcommands. Now we need to define what are the parameters that we want to pass into them. And so for the upload command, at a minimum, we need to have the path to the file that's going to be uploaded and the container name. So let's go ahead and build out the rest of the flag set for upload. And to do that, we'll start with upload path. So we want to create a variable for path. And it's going to build off the upload command. So upload cmd.string. So we're going to create this as a string flag. And we're going to name it path, lowercase. So that's the name. So it would be, upload dash path, and then we would get a path, and we're going to set the default value, which is the second argument here, to just a blank string. And then there's a description, kind of like the help, the comment-based help that we would place here. And this, we'll just say path to file to upload. We kind of know the intention. We'll keep the comment-based help light. So there's the first one. Let's add a little spaces here and add the second flag. So upload, and we want a container. So the container is going to be another string switch. So upload cmd.string, and we'll name it container, lowercase. Again, we'll give an empty string. If you wanted to put a default value there, you totally could. And we'll say name of Azure storage container. Make it a little bit more descriptive there. So now we've got one command kind of built out. I'll go through and just whiz through the rest. It's a little bit repetitive, and then we'll build a switch statement and actually run and test this function. And then we'll start working on building the actual functions inside this that will allow us to upload to Blob, and we can replace our stub function with some real functionality. So here we are, fast forward a little bit. I filled out the rest of the flag sets for the rest of the functions that we wanted, the subcommands, and it looks like it's cutting off a little bit, so we're gonna maximize VS Code so we can see that full line. So just to recap, I added some strings, string flags to download, list, and delete. For download, we needed a few more. We needed a blob name, a container name, and a file. And for list, we just need a container name because we want to list all the blobs in a container. And then for delete, we just needed the name of the blob and the container name. And you can see all that there. And now the next thing that we want to do is to build out our switch statement. So we want to be able to tell Go by our command line arguments which one of these flag sets to run. And we're going to do that by specifying a switch statement. But before we do that, we want to make sure that we test the length, because this command is not meant to be run with one argument. It's meant to be run with a subcommand. So to do that, we'll use an if statement. So if len, which is the length, os.args is less than 2, we're going to throw an error. So we're going to do fumped print line that will display an error. So it'll say expected a subcommand. Keep it really simple, short and sweet. So os.exit, and we'll throw error of 1. So now it's time for our actual switch statement where we're going to put all the logic behind this. So we've got switch, and we're going to switch on the arguments being passed into the first argument, right? So it's going to be azblobcli, and then we're going to pass an upload or download or whatever. And so we want to switch on that value. And to do that, we'll do a switch on os.args, and then that first value that comes in for the subcommand. And then now here comes our case statement. So case would be upload. And this is what the upload is going to do. And then we'll do another case for download. We'll do a case for list. And delete, if I could spell. And so the last thing that we want in our switch statement is a default. So if it doesn't match any of those options, we need to have some kind of a value returned. And for default, we'll actually fill out what it'll do. So we'll do a fumped.println, and we'll say expected a subcommand. So that way, if it doesn't match any of these, or if it's a length less than 2, then we're going to kind of get the same error. Oh, looks like it already completed that for me. So there we go. Now we have our case statement. Now what we're going to do is we're going to use each of these switches to parse the subcommands. And to do that, if we go up to case, let's start with upload. We need to use the parse function of the upload command. So upload cmd.parse. And we want to parse by the arguments coming into the command line. So os.args, and we want to parse 2 onward. So those are the subcommands. So we're excluding the name of the subcommand. We've already identified that it's upload. Now we want to grab the arguments that are coming after that second position. And that way it can fill in all the different pointer information down below. And what we can do while we're calling this the stub function is because we're going to output back to us, we're going to reflect what we're putting in, and we're going to use pointers and println to do that. So if we do fumped.println, we'll start by just saying what the name of the subcommand is. So subcommand upload. So we know what command we ran that it's reflecting back. And then we're going to do a print line for each of the arguments that we passed in, each of our flag set options, and then a pointer back to their value so we can see what we're passing in, just to make sure that it would pass properly to a function when we add that in there. So if we do func.println, maybe do some tabs here. And this would be the path. So we want to figure out what the path is. And we'll do the upload path pointer. And we'll do one for the container as well. And that asterisk is what indicates a pointer. I won't go into pointers, and I won't be able to probably fully explain them to you because I'm still learning how they work on myself. So I'll leave that alone. Just know that the asterisk is a pointer, which is reference to it. It's sharing that value. It's not a copy of it in memory. That's the best explanation I can give you. So this would be the upload container. Okay, so that concludes that line. So what I'll do now is I will go through and speedily update the rest of these as to not bore you, because it's pretty much the same thing. So here we have the completed stub function. We have the case for upload, download, list, delete, and we have all of the print statements to be able to reflect back to us the arguments that we're pushing in. And you notice all the red squigglies went away, which means that we're using all the packages and returning everything properly. So let's give it a try. Let's open up a command prompt and we'll drag it over to the right panel. So that way we can see the code and all the parameters that we need. So we're in the directory where the main file is that we've been editing here so far. So we can either compile this into an executable or we can use the go run command, but let's go ahead and build an executable because Go is a compiled language. And so then you eventually get some kind of executable that's compiled. So we'll do go build and we'll specify the output as az blob CLI. And because we're on Mac or a Linux operating system, we don't really need to put the .exe. If you're on Windows, you would want to put .exe, so that way Windows recognizes it as an executable. So we'll build that, and now we have this executable. So if we clear the screen and we do az blob, / there, az blob CLI. Now we need to use the subcommands to see if they're reflecting back properly. So the first one was upload, and that took a flag or an argument of path, lowercase, and we'll just say maybe, the path is going to be text.txt, and then the container is going to be test container. So here we have it. We have the subcommand. So the subcommand that was output was upload, and then it's reflecting back to us what the path was. So path was text.txt, and the container was test container. Now, if we want to clear our screen, we could do the same thing. If we ran it again and did the list, we could do az blob CLI list, and then all this one needed was a container. So the subcommand that we used that's reflecting back to this list and subcommand. Now let's test the arguments. So remember that we told it to error when there was less than 2 arguments or at least 1 subcommand specified. So if we just run this, we get back the error we expect. And if we give an invalid one from our switch, then we will also get the default message. So maybe there's another operation we could do with blob, which would be like bulk upload that we haven't done yet. And we still expected a subcommand. So there we have it. We have the stub function working, and now it's time to start to put in some of the functionality into this switch. And really what we need to do is just to write some more functions inside Go. And then right about here, this is where we would call the function. So this would be the upload func. And here would be the download func. And list. Oh, and we want to do it after the parsing. So we want to make that clear. So that way we have our arguments. So if we go here, it would be list func. And here would be delete. So to save you some time and to save me some embarrassment, I've gone ahead and created a function script or a file that has all the functions that we need to be able to turn this command line app into something useful using the Azure SDK for Go. So we'll just do a little shake and bake. I will pull up this funcs.go.txt file. We'll take a look at these different functions. Now I've named it .txt at the end, so that way that Go doesn't try to compile this particular example. I just wanted to keep it in the same directory as the function that we're writing or the command line app we're writing, and be able to see it. So if we change the syntax though, let's see here. That way we at least have some syntax highlighting. So what I'll do is I'll just walk through this code, and then at the end I'll copy it into our function, and we'll actually get to see it run. So let's put the focus in on this panel. So the first function is, if we go up to the top, we have this get client function. So if you remember, the whole point of this command line app is to be able to manipulate blob storage within inside Azure storage. And Azure storage has a number of different functions that it can do. It can have containers and blobs and all these other sorts of things. And the Azure SDK for Go has a number of clients to be able to do those different operations. One of them is the Azure Blob client, and that is the primary client that we'll need throughout these functions, because we're uploading, downloading, and deleting block blobs in the context of this command line app. So this is how you declare a function in Go, this funct. You saw that with the func.main. And then you give the name of the function. Now this first character here is important in Go because it's how you make something private or public. It doesn't actually Go doesn't call them private and public, call them exported and not exported. But if it's a lowercase, it's not exported, meaning that it's private, and it can't be used outside of whatever file that it's in. And if it was capital, I could use it across. I could use it as a package library and then import that in and use that function in different packages. But it's private for now. So if we go on into the parentheses, you'll see that there are two arguments that are required to be put into here. These are like the required parameters, so to speak, in a PowerShell function. There is blob and container, and they're both of the type string. So this is something a little bit different. If you've written advanced functions, in PowerShell, you can kind of set the types that you're expecting back, and that will force them to be of that. Go is strictly typed, or is a statically typed language, so that means that everything needs to be identified as a type, and it needs to match, which is very, very interesting. Will throw you for a loop. But outside the parentheses, you'll see that there is this blob, this azblob.block client, block blob client. There we go. Finally said it correctly. And this is the return value. So we've got the function declared, the name. Inside the parentheses, we have the arguments that are coming in to the function, and then we have our return value. You don't have to return something, but you can. Now, what's interesting about Go is it can actually have multiple return values, but I won't get into that. So the first thing that we're doing is we're getting an environment variable. So you'll notice that I'm using a lot of these packages that are all part of the standard library in Go, and these are basically what comes with Go that you can use for free without taking any external dependencies. Now, when we get down to the AZ blob and AZ identity, these are external packages that we'll have to add to our import statement. But back to line 2, this os.getEnv is just getting the environment variable and populating that as a variable called storage account. So I'm using this as a way to set up my environment. So instead of making this another parameter that's accepted, I'm just saying, if you want to run this function, you have to have this environment variable set. This lends itself well to being run in a Docker environment, or even in the command line too, where you're setting up. Terraform does a very similar thing. They require you to have certain parameters filled out before the code functions, before you can run Terraform and stuff like that. So on line 4, what we're doing, or what the code is doing, is it's creating a cred variable. So this is the short variable declaration where it instantiates and creates a variable at the same time. So we have cred and air. So it's returning two variables. One would be air and one would be cred, and it's using the AZ identity new default Azure credential function to be able to authenticate to Azure. This credential type has a number of chained tokens that it can use, or chained methods. So one of them is that it can use your AZ CLI token to be able to authenticate, and that's what I'll be doing here. Is I've already authenticated to Azure with the AZ CLI, and so I'm just going to share that token with Go using this credential type and be on my merry way and not have to worry about service principals and stuff like that. What you'll see on lines 5 through 7 is probably the most common error handling method in Go, which is this: if the error does not equal nil, then return a fatal. So if we do get some kind of an error back from the AZ identity, we shouldn't continue on and we should error out. So we want to error out as soon as possible, and that's what line 5 through 7 does. On line 9, we're creating a blob URL. So this is part of what we need to be able to create the client. We need to figure out, which blob are we connecting to across all of Azure, and we do that by these URLs. And these URLs are pretty static, so we can predict what they're going to be. They start with HTTPS, and then there's the storage name, and then there's the container name and the blob name all included in the URL. And so what I'm using is this sprintf function from the fump package to be able to concatenate that string. This would be something very similar in PowerShell would be the join operator or the join function that you would want to use. And this %s is just an operator inside the sprintf or the fump package that allows me to replace these particular sections with strings. There's percent signs for like %d would do a digit and so forth. So there's different ways that you can format the string, and the s is just a normal string value. PowerShell kind of takes care of that for you a lot of the times. But if you look down on line 11, we're finally getting to the point where we can create the client, and we're using the AZ blob package to do this with the new blob client. And again, that takes the blob URL, a credential to authenticate to Azure, and then these are just options that you could pass into the client, and I'm going to pass in nil for that. And again, we're going to check for the error to make sure that we're not erroring out on creating the client, and then we return it. And then that is actually what returns of this type. So this, whatever this variable is here, has to have the same type of whatever we declared up here. And that's what what means by Go being a statically typed language. On line 18, we have our upload function. So the upload takes a path and a container. They're both strings, and it doesn't return anything. We could have it return back a print message or something like that if we wanted to. But if we go down here to line 20, we're getting the content. I'm using the IO util. All of these are a lot of the standard library ones, so you just kind of have to figure out. It'd be no different than if you were browsing the PowerShell help system and trying to figure out like, oh, how do I use get content? How do I use this thing? And these are all the standard library packages that you can use to kind of figure out how to do these operations that you already know how to do in PowerShell and write them in Go. So that's the IO util read file. So that read file takes a path, and that path is one of the arguments that is passed into the function. And again, we error out if we need to. Line 25, we are creating the blob name. So this file path split is kind of like a specialized split operator, so to speak, for PowerShell that allows you to split a file path. And the second part, or the second value that returns, is actually just the name. So I'm using this to get the name of the file or the last part of the path, and I'm using that as a blob name. So if I passed in text.txt, which we will do in a little bit, that actually becomes the blob name. So that way I could reduce another parameter from the upload function. Just give me a path, I'm going to split it, I'm going to grab the name of the file, I'm going to use that as a blob name. Then down here, we're creating a client. So instead of having to repeat that code, remember the pragmatic programmer drive principle. You don't want to repeat yourself and repeat your code. And so here I'm just calling that function and giving the blob name and the container name that are both, one's passed in from the argument, another one is constructed from the file name or split from the file name. And then I'm uploading. So this client, now that we have the client, we have the functions available to us. We've authenticated to Azure. We have a blob client, and now we can start to do some operations. And so this client.upload buffer to block blob takes a context, the content. So, what is it going to be made up of? And then it takes this option block. And so this was mandatory for one reason or another. I couldn't just pass nil into here. So I'm creating a blank structure of this type of this high-level upload block options. And so I'm essentially what that's doing is just, here's the default options, and I want those. There's a number of things that you can change there, and then I'm erroring out. And a very similar thing for the download. Again, I'm going to pick up speed as I go through here because it's kind of the same thing. I'm passing in the arguments that are needed. I'm not returning anything, creating a client, getting a destination file, and I'm creating it. So I'm creating this destination file because I'm downloading. I want to create a new file. And then I want to download the file's contents into the destination file. And then I'm going to return nothing. So this underscore is called a blank identifier. And it allows you to kind of just throw away the output. So if in the instance in this code, we don't actually care about any of the returns that are coming from the download blob to upload. And Go forces us to handle those. We can't just leave them there. unreturned, but if you use the blank identifier, you can say discard, and that's a way to bypass that feature of Go. The list is a little bit more lengthy and interesting because it uses a pager, and a pager uses pagintation, I believe is how you say that, and that will just basically loop through all the options. But this needs the storage account because the list actually uses a different client. So instead of creating another function, again, bear with me here, there is a lot of improvement, and I think this is kind of the main point that I wanted to get across to this talk is you can write something like this and get over that first hurdle, because once you've written something, you can find a billion ways to improve it. And so there's a lot of improvement here. But what I needed to do for the list function is I needed to create a different client. And so I'm getting that environment variable again, and I'm creating a different container URL minus the blob, because to create a container client, I need the storage URL, but I don't need the blob portion of it. And so I'm creating a new variable called container URL that allows me to do that. And I'm creating another credential. So there's a little bit of repetition here that I could weed out, but at least now I have some code that I can start to massage and make better and improve. And it kind of gives me over that hurdle of like, what do I do? What do I write? But anyway, if we move down to line 56, this is where we're creating the new client. The new client takes the container URL, the credential, so forth. And then we're creating a pager. And this pager is created by the list blobs flat. So we're just listing all the blobs flat. We're not getting any details, we're really just getting their names. And then I'm doing a for loop. So each pager for each pager.next page, I'm passing a temporary context or to-do context. And then inside that, I am creating this response variable. So for each pass, this is kind of like a for each loop in PowerShell. Go doesn't have anything other than the for loop, which is pretty interesting. It's actually pretty cool. But if we go through here, we're doing a for each response. And then we're creating a response for each pager response. So basically each page that's in there, create a response variable. And then we're going to loop through that. So for each response, we're going to throw away the first value. We're going to throw away the key rather, because this returns a key value pair. And we're going to take the value and we're going to print it out to the screen or create a pointer to that value. So, and I'm even going to go even further and say, I don't want the full value. I just want the name of the value, because it has other information about the blob that with inside a container that I don't need. I just want to list the names. Now, what I should do here is I should probably create some kind of a variable and append it to it, maybe an array or slice or something like that, or maybe even a map if I care to list the container that it came from, and then return it instead of just printing out this line. Because although it doesn't say I return something, I actually print something to the screen, and so that's definitely somewhere we can improve. And then lastly, we have the delete. Delete's pretty interesting as well, because I'm actually returning the return types of the method or the function that I'm calling for delete. So I'm just wrapping this around the existing functionality of the AZ blob delete blob response or delete blob. And again, I'm creating a client to the block blob, passing in the name and the container. And then I'm just returning whatever the delete call returns. So I can just basically pass that up. And so as long as my return types of my function match the return types of delete, I'll be able to do that. And so that's one way that you can kind of wrap a function around a particular package or a function inside of a package. So that's all the code. What I'll take a minute to do now is I will move all this into our code, and then we'll actually start running at the command line and create some files to upload to Azure Storage and take a look. All right, so here we are back at our main.go file, and I've moved in those functions. So if we scroll to the top, you'll see that I just put them all above the main function inside of our main.go file for our command line app. And if we go back down, actually, if we go to the top, you'll see that all these imports were taken care of for me. So I'm using VS Code. There's a Go plugin or extension for that. And essentially what it'll do is it'll take care of all your dependencies. So as you start to use different packages, if it can resolve them, it'll just add them into your imports. So if you look at the top here, these are all the standard packages that I'm now using. And then here are the external ones that I'm using from GitHub. And you can see, as you saw in the samples, I was using Azure Identity, AZ Identity, and AZ Blob. And so if I save that, that'll stick there. It'll also annoyingly remove ones that you haven't yet fully used. So just, it's a double-edged sword. Anyway, if we go back down, the biggest change is inside of our switch. So instead of all those print statements, I'm now just calling those functions that we wrote to manipulate blob storage. And so if you look at upload, I'm calling the upload and I'm passing in a pointer to the upload path, the upload container, and the same thing for download, list, delete, and so forth. So now we're ready to actually go through and run this and see if it actually does anything for blob storage. So to begin, let's maximize the shell so we can see that a little bit better. Let's build out our new tool. So go build -o and then az blob CLI, capital B. And it looks like we need some dependencies. We can't yet build it because we need to go and get these modules online. So we can just copy these lines here to grab the Azure Identity package, and then we'll grab the blob as well. And this is going to put it into, it's going to download it. So our local Go instance for this module has those packages available to compile. All right, so it looks like I've got both those packages now. I'll clear the screen. Let's see if we can build our command line app again. So now we have the command line. If you remember, the first thing that we needed to do before we could run this is to set an environment variable. And because I don't remember what that name of the environment variable is, we'll come into the code and we'll grab it. Okay, so Azure storage account. Now I'm on a Mac, so I need to use the export command because PowerShell doesn't share variables with the system. So we're going to say that this equals, and this will be my storage account. So I think my storage account is my storage account is my storage account 002. We'll set that as the environment variable, and now we should be ready to run the command. Now the other thing that we need to do in order to upload something is to have a file. So I'll use Vim and we'll just create a text.txt with some hello world in there. Looks like I already did that. So we'll just save that file, and now we can run our upload command. So az blob, there we go. Upload path is going to be this text.txt. And then our container I have is test container. So I'm assuming there's some Azure infrastructure already built in the background. I have a storage account and I have a container already built. I'm not going to walk through that. Container. And let's see if it runs. So the upload worked just fine. Now we could either switch to PowerShell or we could use our list function to figure out what's in that particular container. So if we do az blob CLI list, and then we just needed a container. And that container is test container. We can see that it did pull back to text.txt, but we don't know what's in there, so we can use our download function. So az blob CLI download. And I think we needed the blob itself, I think was the parameter. And if we're confused on that, we could go to download. It looks like it needs the name. If we scroll down to the functions, yeah, we need the blob name, which is just name. Okay, so we need name. And the name is text.txt. Remember, it parsed that. And then we need the container, which is test container. And then we need a destination, which I think was, if we look back at there, the argument was file. So this is the file that we're going to put it into. So we'll just say downloaded file .txt. And if we do an ls, we've got this downloaded file. And if we cat that file, hopefully it has hello world. And it does. So there we go. We got it all uploaded, listed it, and we downloaded it. So let's see if we can delete it. Easy blob, delete. And then I think we needed the blob name, which is just name, txt. And then we needed the container. Not defined container. Did I spell container wrong? Yes, I did. Container. Okay, so let's run another list. Or clear. And then we'll up arrow to the list call that we did. And now it lists nothing. So we just tested all of our different functionality in our command line app that we built for Go using Azure Blob Storage and the Azure SDK for Go. Before you go, no pun intended, I want to leave you with a learning technique that has helped me tremendously acquiring new skills. It's called the Feynman technique. A short while ago, I posted a video on YouTube that walks through my process of using the Feynman technique to take technical notes. If that sounds interesting to you, please check out my channel, leave a comment, and maybe even subscribe. With that, I'd like to thank you for your time. I'm honored to have had the pleasure of presenting to you today. I hope you have a wonderful day, evening, or night, and enjoy the rest of the conference. Everybody, thanks for watching. Hope you enjoyed it. I can stick around for a little bit if there's any questions. I'll make sure that all the links that I reference in the slides and snippets and gists and stuff like that were part of the talk are provided with the recording. But they're on the slide deck. I'll make sure that the organizers get that information and you'll be able to have that as well. But like I said, I can stick around for a little bit for questions. Yeah, but thank you again for attending. Yeah. Here, I'll put a link in Zoom. I don't know if you guys can share that out to them. But I also, if you just put in YouTube Josh Duffney, it's my latest video, you'll be able to find it. Okay, well, thank you all so much. See ya. Enjoy the rest of the conference.